Yes, ma'am.
All right. Thank you. Thank you so much. So, before we start with descriptive statistics, it is very, very important for all of you to know that why do we study statistics or why is statistics important? Now, very recently, I request you all to please mute yourself so that there is no disturbance within the class. Now, as you all know, that very recently in the month of June, June end, we observe National Statistics Day, and this year the theme of the Statistics Day was very related to what is the essence of statistics, and that is how data brings evidence. So now the world is realizing and moving into evidence-based decision making. Now, just raw data or just presentation of facts without base is not considered to be a valid or a reasonable solution to any problem. If there is a solution that is considered reasonable nowadays, it has to be supported with data. So, I mean, statistically literate or statistical wisdom is nowadays considered to be extremely important. The world is moving towards evidence-based decision making. The world is moving towards informed decisions. And in order to take informed decisions, we need to have evidences from our data. And that evidence from the data can be given using statistics. So as we all know, we convert raw data into meaningful information using statistics. So this is the importance of statistics, and I think data is everywhere. While we are talking to each other, that is also data. So to convert that data into meaningful information, that is done by statistics. Now, before we discuss about statistics in detail, I think it is important for all of you to know something about data. Now, data is broadly classified into two sections, primary and secondary data. I think most of you must be aware of this. Primary data generally is collected by a user and or by a researcher through a well-developed questionnaire that is developed by the researcher. While a secondary data is collected by certain organizations, NGOs, and those data sets are used by other people if the objectives are aligned, and those kinds of data sets are known as secondary data. So when you use an already collected data, that's known as secondary data, and when you collect data on your own, that is known as primary data. Now, also, there are two terms which are very commonly used when we talk about statistics, and those terms are variable and constant. Now, any quantity that varies from individual to individual, that is known as variable, and which remains constant or fixed, that is known as constant. I think these are some very basic definitions which most of you must be aware. Now, when we talk about variable, it is extremely important to know what is the categorization of variable. How do we categorize different variables? Now, why this is important, I am not sure or not aware if you people have studied this before or not, but it is extremely important to know this categorization or the types of variables, because later on when we do statistical analysis, there are many types of analysis which could only be done for a specific type of variable. So it is very important that you know how the variables are categorized. So broadly, we can categorize variables into two sections, qualitative and quantitative. Now, if I define qualitative first, then as the name suggests, it relates to quality or an attribute. Now, what does quality or an attribute means? When we talk about some characteristic of the population, which is capable of being categorized. You can categorize or like classify it into categories, but you cannot measure it. Okay, so it is an attribute, it is a quality which is capable of being categorized into different classes, but you cannot measure it, you cannot quantify it. Those types of variables are known as qualitative variable, also called categorical variable. Some of the examples of qualitative variables could be gender, like if I say male, female, or now there is another third gender, and we have different gender classifications now. So this type of variable is a qualitative variable because we are talking about certain quality or a attribute. Another example of qualitative variable could be your caste, could be your religion, could be the color of your hair, could be the color of your skin, the color of your eyes, anything, right? So all these types of variables are known as qualitative or categorical variable, also called non-numeric. Now, these qualitative variables can be further classified as nominal and ordinal. Now, what is the difference between the two? In nominal, we don't have ordering. Okay, there are categories, but there is no ordering. Example of nominal variable could be, again, as I said, gender. We cannot order it. Caste, religion, color of eyes. All this is example of nominal type of categorical variable. While on the other hand, ordinal type of categorical variables, we have ranking. Okay. So, for example, suppose if I say that level of education, okay, primary, secondary, higher secondary, okay, then graduate, postgraduate, and above graduate. Now, if I categorize education level as in this form, this is an example of ordinal variable. Another very like related to real life example would be, you all must have gone to watch movies. You all must have gone in a restaurant. Now, whenever we go to a restaurant or whenever we watch a movie, after the movie or after eating, we are given certain like feedback forms, right? That how did you like the movie? So on a scale of 1 to 5, please rate how did you like the movie. या फिर like sometimes you are given a feedback form where there are smileys made. You have a sad face and you have a smiling face. Okay. And you have to rate a movie. So all these types of variables or these types of scales are known as ordinal. Okay. Where you have ranking. This is one more example of ordinal type of variable. Another example could be, I'm assuming that we also have professionals who have joined here. So in medical field, if I give some example, then I can say anemia level, mild, moderate, severe. Okay, this is again an example of an ordinal type of variable. Okay, so this is also categorical, non-numeric, but it is in ordered form, ranking. Okay, coming to quantitative, any variable which is capable of being measured or counted is known as quantitative or numeric variable. I am repeating the definition once again. Any variable which is capable of being counted or measured is known as quantitative or numeric variable, also called metric variable. Now, what do I mean when I say counted or measured? I hope you all understand the difference between count and measure. Count means that I can count the number of chairs in this room. Okay. You can count the number of members in your house. But when I talk about measurement, you can measure the height of members in your house. You can measure the weight of members in your house. So the basic difference between count and measure is count is discrete while measure is continuous. In a house, there will not be 3.5 children. Either there would be 3 children in the house or there would be 4. Okay. In a house, there cannot be 3.5 chairs. So discrete. This is one more classification of numeric or quantitative variable. That is discrete and continuous. It is not written here on the screen, but this is one more type of classification of numeric or quantitative variable, and that is discrete and continuous. Discrete means distinct, while continuous means that on a number scale there are continuous observations. Height, weight, these are all examples of continuous type of variables, while anything that is counted is an example of discrete. Further, quantitative variable can also be classified as ratio and interval. Now, what is the difference between the two? In ratio scale, we have true zero, while in interval scale, there is no true zero. Now, what is the difference between true zero and no true zero? Can anybody tell me the difference? I would be happy if anybody of you can answer. Let us make this as an interactive session. Anyone who can tell me the difference between ratio and interval?
Ma'am, like if there is a temperature in at 0 degrees centigrade, then this is an interval scale. And if 0 Kelvin, then this is ratio scale.
If it is in Kelvin, it is ratio scale, and if it is in degrees Celsius, it is interval. Okay, very nice, wonderful. Can you explain this also? That what ratio and interval means? Very good. Dr. Kaur, can you explain this also?
Ma'am, sorry, ma'am, not very much I can explain it, but
okay, no worries, but you've given a wonderful example. So what she said, that temperature measured in degrees Celsius is an example of interval scale, while temperature measured in Kelvin is an example of ratio scale. What does this actually mean? In degrees Celsius, when we say 0 degrees Celsius, so what does it mean? 0 degree Celsius का मतलब क्या होता है? If temperature is 0 degree, it means that
we can have temperature in minus also.
You can have it in minus also, yes. 0 degree Celsius means so, that it is.
Ma'am, 0 degrees Celsius means the boiling point of that temperature.
No, boiling is 100. Boiling is 100. 0 means freezing point.
Yes, ma'am.
Yeah. So, 0 degree Celsius means that it is very cold, right? Now, in interval scale, 0 has some meaning. While when we talk about ratio scale, 0 means nothing. Okay. Suppose if I say that weight is 0 kilograms, what does this mean? This means that there is no weight.
No weight, yes.
Yes. If I say that height is 0 degree, or 0 centimeters, then this means that there is no height. So wherever 0 means nothing, that is known as ratio scale. And wherever 0 has some meaning, that is known as interval scale. In other words, I can say If there is true zero, then that is called ratio scale. While if we don't have true zero, that is called interval scale. Can anybody give me another example of interval scale other than temperature, where zero means something?
Score.
Score. Okay. Can you please explain it more? What do you mean by score? Like if a
Means that,
person has got 0 marks, then
yes, that's the meaning. So that's called an interval.
No, actually, this is very subjective. If a person has got 0 marks, then you can say that a person has got no marks, right?
Yes, ma'am.
Yeah, but I'll give you another example. Have you all heard of pH? pH scale.
Yes, ma'am.
Yeah, which measures whether, like, if we do it for soap, that how acidic it is, how
Yes,
neutral
and
it is.
negative log of hydrogen ion concentration.
Yeah. So what 0 pH means? Can anybody tell me? If the pH value is 0, what does it mean?
Neutral.
No,
it is
does
highly
not
acidic.
mean
It is
neutral.
highly acidic.
It is
It
acidic.
is highly acidic. Absolutely correct. Yes. So pH 0 means it is highly acidic. pH 0 does not mean कि उसका pH ही नहीं होगा. Like neutral, ऐसा नहीं होगा. So pH is another example of a variable which is on an interval scale. Gravity. Even if gravity is 0, it does not mean कि gravity ही नहीं है. So variables like this, where 0 means something, is known as interval scale, but where 0 means nothing, that is those variables which have true 0, those variables are known as ratios. Now, one more very important thing, among all these measurement scales or types of variable, ratio scale is the best type of variable. Why I am saying this? Because all mathematical operations are possible on ratio scale. Since we have true 0, therefore multiplication, division is also possible. Addition, subtraction is also possible. In case of interval scale, since we do not have true 0, therefore multiplication and division is not possible for interval scale. Therefore, among all these 4 different types of variables, ratio scale is supposed to be the best type of scale or best type of variable. Okay. I hope this difference is clear to all of you. These basics are extremely important. So even if you have studied this, it is a quick revision for all of you. These things are important because, I mean, you all must have heard of this story that it is always better to sharpen your axe before you are cutting a tree. So all this is sharpening of your axe. So the sharper the axe is, the faster you will be able to cut the tree. Okay. These are different types of examples of nominal, ordinal, ratio, and interval scale variables. Most of them are medical type of examples because my specialization is in biostatistics. But I think these are very commonly used variables, which all of you will understand. Some of the examples. Yes.
Here IQ level, can IQ be in minus? I don't think so.
Sorry, could you please come again?
Interval you have written IQ level, but IQ, can it be negative? I don't I am not aware that IQ can be negative also.
Interval scale does not always mean that it is negative. If a variable is on an interval scale, it is not, I mean, it does not imply that values would be negative.
So I didn't get it. Means it is the least is 0 only. So how can it be?
Yeah, even if the least is 0, variable can come under interval scale. Here, the reason why I have written IQ level in interval scale is that even if a person has IQ 0, does not mean that a person has no brain.
Brain. But
So ma'am,
ma'am,
I think in interval data, if the value is 0, it means it is very low. It does not mean ki it has nothing.
Yeah, that's what I'm saying. That since it is not true 0, so even if a person has IQ level 0, it does not mean that a person doesn't have any IQ. This is what it means here. That is why I have written IQ level in the interval scale and not in ordinal or
ma'am,
ratio.
if the IQ is 0, how can we say that the patient means the person has any IQ? Means
So that's what I'm saying, that if the IQ level is 0, it does not mean that the person has, like, the person is not able to think or a person has no brain. It means that his intelligence quotient is 0. That's all. But here 0 does not imply that he has no brain, or like it does not imply that it is nothing. Okay.
It's about way of measurement. Like in temperature, in Kelvin, there is 0 in Kelvin means no temperature. But in
Yeah.
0 doesn't imply that.
Yeah, that's what I'm saying. It's the way of measurement of this variable.
IQ is just a theoretical way of measuring intelligence, not complete understanding and everything.
Yeah, just
That's
by
what I
the
mean.
basis of intelligence quotient, you cannot completely determine a person's intelligence level. I hope you're able to understand, Dr. Gupta.
Sure, ma'am. Thank you.
Yeah. Okay, so this is what I've already discussed, that these are different types of operations which could be performed. And as I said, ratio scale happens to be the best because all types of mathematical operations, along with counting and ranking, could be done on a ratio scale. Now coming to the topic that we are supposed to discuss today in brief, that is descriptive statistics. Now, statistics is broadly classified into two sections, descriptive and inferential statistics. Now, I'm sure you have some idea of what is descriptive and what is inferential statistics. But very briefly, I would explain this to all of you. Now, whenever we go to doctor, I mean, anybody of us, if we go to a doctor or any of our relatives go to a doctor, nowadays, if we have a fever, what is the first thing that a doctor does? That's my question to all of you. Suppose if you're having fever for say 4-5 days and then you visit a doctor, what is the first thing that he or she is going to do?
Check temperature.
Temperature, blood test.
Okay.
Blood test.
Blood test. Very good.
Take a
No
sample.
diagnosis nowadays is done without series of tests. You are being given a series of tests which have to be done, which includes say complete blood count, then typhoid, malaria, etc., etc. And only after the results of those tests are out, only then a doctor determines that what is the cause of your fever, whether you should be given just a paracetamol or you should be given some medicine to treat the disease that you are having because of which there is fever. Now, those blood tests are exactly what descriptive statistics does to your data. It is a diagnosis that you do to your data set to understand whether your data has outliers or not, whether your data has extreme observations or not, whether the variables are normally distributed or not. Okay, what is the distribution of variable? Different types of descriptive statistics measures and so on. So descriptive statistics is basically those tests, those preliminary tests which you do to your data to understand the nature, the behavior of the data, and what all inferential statistical measures should be applied to your data. Whether you should go in for parametric testing if it is normally distributed, whether you should go in for non-parametric methods, if it is non-normally distributed, and so on. So descriptive statistics is just like those diagnostic testing, which is very, very important to understand the nature and the behavior of the data. Okay. And after you have been able to describe your data, we then perform inferential statistics. Okay. So broadly, how is descriptive statistics done? On the basis of different types of data or variable, which I just now discussed, broadly, we can classify it into qualitative and quantitative. So for qualitative types of data, we either go in for frequency distribution, that is simple percentage distribution. And if the variables are quantitative in nature, that is numeric, then there are three ways by which we describe our data. And all these three ways are equally important: center, variability, and shape. So I think frequency percentage must be clear to all of you. It is the
What is the
number
difference
and the
between them?
percentage.
What is the difference between frequency and percentage means?
Frequency is the count, and in percentage, using that count, we take out the percentage. So we
Okay,
also
that's
take in the account the denominator. Okay.
right, ma'am. So N is the frequency and percentage is means for the
Yeah.
percentage.
Percentage is calculated using the frequency.
Right.
So in case of qualitative, we go for frequencies and percentage. And in case of quantitative, we go for center, variability, and shape. So I think qualitative is clear. We discuss in detail how we describe quantitative set of data. So first we begin with center, that is measures of central tendency. Now, very quick question to all of you, since you have studied descriptive statistics. Why is it always called measures of central tendency? I mean, I'm sure you people must have studied some book or the other of statistics. And in any statistics book, if we come across, it is always written measures of central tendency. Can anybody explain me this word central tendency?
Ma'am, I think because when we
It gives the idea of a mid value.
average value somewhere we are finding out in our data set, which is central oriented, we can say.
Can you please repeat?
Ma'am, actually in any data set, we find this average value and the central values, so that all the data is surrounded nearby that central value.
Yeah. Very, very nice.
And they are basically average.
Yeah, it is average, but now why it is called tendency? Now,
Actually, ma'am, because data has the tendency to gather around one point.
yes,
It is
very nice. So it is every data set has this tendency to come near a center value. Okay, so average doesn't always mean that it should lie at the center only. Average means it is one particular value in that data where all the observations are coming towards that value. That is why it is called central tendency. The tendency of your data to come to that particular point. It could be exactly at the middle, or it could not be at the middle. So always remember, center doesn't always mean the mid value. Center, that is why it is not called measures of center. It is called measures of central tendency. The tendency of the data to come near a central value, which could be the center, that is the middle, or it could be anywhere in the data. Okay, I hope this is clear. It's actually a very basic thing, but people don't understand the difference between center and central tendency. That's why I thought to discuss. Now, these are some of the popular measures of central tendency. arithmetic mean, median, mode, geometric mean, harmonic mean. Very quickly, I can explain this to you. Broadly, we classify central tendency measures into two: positional average and mathematical average. Positional averages are those which are calculated using the formula, and positional averages are those which are based on position or location, which you can also identify graphically, like median. Then there are quartiles, deciles, percentiles. Quartiles divides your data into 4 equal halves, deciles into 10, percentiles into 100. Mode is that particular value which very frequently occurs, which has highest frequency of occurrence. Then arithmetic mean, I think all of you know the average. Then you have a geometric mean, which is used mainly for ratios, rates. Then we have harmonic mean, which is used for inverse relationship type of variables. So arithmetic, geometric, and harmonic mean are called mathematical average, whereas median, mode, and these quartile, deciles, percentiles are called positional average. Now, this is the formula for arithmetic mean. I'm not going into the details of these because I'm assuming that you all already aware of this. Arithmetic mean is the sum of all the variables divided by the number of observations. Advantages and disadvantages of arithmetic mean, very, very important to know. We cannot calculate arithmetic mean for a qualitative type of variable, that is gender, caste, religion. So you can only use it for quantitative data. Number two, it is highly affected by extreme values and outliers. Even if one observation is very high or very low, your mean will be highly affected. And one more disadvantage is that you cannot calculate it for open classes. Open classes means when you have a grouped data, and in grouped data, suppose you have class intervals like less than 10 or more than 100, and like where you don't have lower or upper limit, then you cannot calculate the middle value. And since you cannot calculate the mid value, so it will be not possible for you to calculate mean in that case. Advantages are many. I think most of you must be aware. It is very frequently used. It is unique. It is based on all the observations. So some brief about mean. Then median, it is the middle value, divides your data into 2 equal halves. This is how you calculate median. There are 2 different sets of formula. This is for even, the lower one, and then you have odd number of observations, so formula is changed. And for grouped data, we have different formula. Grouped means when you have data in the form of class intervals. Now, one advantage of median as compared to mean is that mean is highly affected by extreme values or outliers, while on the other hand, median is not affected by extreme observations or outliers. So in your data, if you have extreme observations or outliers, or in other words, I can say, if your data is skewed, I hope you all must be aware of skewed. Skewed means departure from symmetry, which means it is not normally distributed. So if your data is skewed, median is a better measure of central tendency as compared to mean. Okay. Then we have mode. Mode definitely means that the observation that occurs most frequently. Mode is easy to calculate, but it is not at all a good measure of central tendency. Why I am saying it is not a good measure? Because number one, it is not necessary that mode is always unique. Median एक ही होगा data का, mean एक ही होगा, but mode can be more than one. So first, mode is not a unique measure. Secondly, there are data sets for which mode will not occur. I mean, it is at times indeterminate. But for every data, you will have a median and you will have a mean. You can see in this slide, there are few examples that are given here. The blood pressure levels are given, and here 86 is the mode because it occurs 4 times. Then in the second example, there are 2 modes, 9 and 25, because both these observations are occurring twice. In the last example, there is no mode because all the observations are occurring only once. So this is one of the disadvantage of mode. That is why it is easy. It is very simple, but it is not at all a reliable measure of central tendency. Now this is the formula for mode, not going into the details. This is on the left, you can see a graph that is unimodal, having one mode. And on the right, you can see it's a bimodal. So there are 2 modes. Then after mode, as I already discussed, quartile, deciles, and percentiles, these are also measures of like central tendency, and they are called positional or locational average. Quartile divides into 4 equal parts, decile 10, percentiles 100. Now, as you can see on the screen, you have a minimum value, you have a maximum, then you have first quartile, 25% observations less than first quartile. Then you have second quartile, which is also called median. And then you have third quartile, where 75% observations are less than. And then you have the maximum value. After center, another very important measure of central tendency is called dispersion. Now, can you see this figure, which is shown on the screen, everybody? I hope it is visible.
Yes.
Yes.
Can anybody
Yes, ma'am.
just tell me what is the difference between the 3 curves that are drawn here? A, B, C. What is the difference between the 3?
Platykurtic, mesokurtic, I mean, kurtosis.
ये तो थोड़ा ज़्यादा हो गया. अभी हम kurtosis पर नहीं जा रहे. Just talk
Spread
in
of
terms
data.
of either central
Distribution
tendency
of the
or
data.
The base is wider.
the base
Mode is
is
different.
wider. Okay.
All of
और बताइए.
Scatteredness, data is scattered in C.
Data is scattered. Very nice. I think we also have something on the chats. Variation is high, more dispersed values. Yes. Wonderful.
Difference in every curve.
So I'll explain. Now, all the 3, A, B, and C, all the 3 curves have center exactly at the same point. If you can see, तीनों का peak से अगर if we draw line on the x-axis, the center is exactly the same. But if I say A is less scattered, B has a wider dispersion, and C has like it is most dispersed among the 3. This clearly indicates that solely on the basis of measure of central tendency, we cannot and we should not define any data. Now, I will give you another example. I think some of you must be into research or you will be into research. Any research paper that we come across or study, in the first table, that is usually the descriptive statistics, everywhere you will see it is written mean plus minus ST. Nowhere will you see that mean is reported in isolation. This is what this figure actually means. No measure of central tendency should be reported in isolation. You should always combine measure of central tendency with measure of dispersion. Then only it will be a complete description of your data. If you don't want to report mean and standard deviation, or like if your data is skewed, then we go for median and interquartile range. Okay, so it is not necessary that you always report mean and standard deviation, but you should combine a measure of central tendency with a measure of dispersion, only then your distribution is complete. Description of your data is complete. Okay. So in the measures of dispersion, we discuss about three measures of dispersion, two broad categories, absolute and relative. Now, what is the difference between the two? Relative measures are unit free, so they are generally used for comparisons. Whereas absolute measures, you have unit, so they are not used for comparison purposes. So the first and very simple measure of dispersion is range. Range is the absolute measure. Range means difference between highest and the lowest, or largest and the smallest. And its relative measure is known as coefficient of range. This is the formula. A measure slightly better than range is known as interquartile range. Interquartile range is actually the difference between third quartile and first quartile. You all know what is third and first quartile. So interquartile range is slightly refined as compared to range, because instead of just taking the maximum and the minimum value, it takes third quartile and first quartile. The measure based on interquartile range is known as quartile deviation. As you can see on the screen, formula is Q3 minus Q1 by 2, and its coefficient or the range relative measure of dispersion is given as Q3 minus Q1 divided by Q3 plus Q1 into 100. Normally, we multiply relative measures by 100 and we report them in the form of percentages. If you don't multiply it by 100, then you would not be reporting it in the form of percentage. Even better than quartile deviation is known as mean deviation, where, just as the name suggests, we find out deviation from the central value, which is not necessarily mean. It could either be mean or median or mode. Any central value, we try to find out the deviation from that value. That is called mean deviation. A measure even better than mean deviation is known as standard deviation. Here also we take the difference from the mean. Then we take out its square and then the square root of the difference. This is known as a standard. This is supposedly the best and the most robust measure of dispersion. But this measure of dispersion, that is a standard deviation SD, should only be used when we deal with data which is normally distributed. Their mean is appropriate. Only when mean is appropriate, then we should use standard deviation as the measure of dispersion. Variance is the square of a standard deviation. This is the relative measure of dispersion, which is known as coefficient of variation. Now, one more very important concept which I wanted to discuss with all of you today when we talk about descriptive statistics is this box and whiskers plot. This is used for many purposes. Number one, it tells you about the distribution of your data. That is, whether your data is normally distributed or not. Number two, it helps in identifying outliers. Number three, it helps in identifying extreme values. Number four, it is also useful in comparing different data sets. Now, let us begin with how you can identify that whether your data is normally distributed or not using this box and whiskers plot. As you can see on my screen, this box here, the central value, which is marked with a red vertical line, indicates the median. The line on the left is your first quartile, and the line on the right is the third quartile. Okay. Then there are two dotted lines. The line on the left is known as the left whisker and the line on the right is known as the right whiskers. This line on the left is made at point Q1 minus 1.5 times of interquartile range. What is interquartile range? This difference is known as interquartile range, Q3 minus Q1. And this line at the right is made at Q3 plus 1.5 times of interquartile range. Now, if the data is normally distributed, all these distances would be equal. Okay, I'm repeating it once again. If the data is normally distributed, all these distances, distance between this and this, then the distance between Q1 and median, median and Q3, Q3 and this line, all these distances would be equal if data is normally distributed. Secondly, values which are beyond these points are known as outliers. And values which are beyond Q1 minus 3 times of IQR and Q3 plus 3 times of IQR here on the right are known as extreme values. I hope you all understand what is the difference between outlier and extreme observation. I will explain this to you with the help of an example. Suppose if I take height of all of you who are present in the class today, some of you, like most of us in Indian population, height would be somewhere around 5, 4'10", 4'11", se leke, it will go up to 5'5", 5'6", 5'7", maximum. Some of you, very few, might have height, say 6 feet or 6'1". So those people who have height, say 6 or 6'1", they are called outliers. Why? Because the value is slightly beyond the rest of the values of our data. Now, there could be some individual, or maybe 1 or 2, who has height, say 6'2", 6'3", maybe 6'5". I mean, very different from the rest of the observation. Those values are known as extreme values. You can see it in this graph. This is also box and whisker. The only difference between the two is that in the left one, it was like horizontal, and here it is vertical. That's all. Now, extreme values are denoted by star. We will make this in R also, and then you will understand it better. Extreme values are denoted by star, and outliers are denoted by O. So, outliers, they may be present in your data and they are important for your data. I mean, they tell you the nature of your data. But if extreme values are present, extreme values needs to be, you need to verify each and every extreme value that is present in your data. By verify, I mean you need to check why is that value present in your data. So each extreme observation has to be investigated. And this box and whisker plot, very important tool for data pre-processing, for data cleaning, helps in identifying outliers and extreme observation. And it also tells you about the distribution of your data. Okay. Lastly, so we've discussed about center, we have discussed about dispersion. Lastly, we discuss about shape. Now, shape you can tell using two different measures, skewness and kurtosis. Skewness, I'm sure everybody must be aware. This is a graph, a figure where there is zero skewness, which means no departure from symmetry. It is symmetrical, also called normally distributed. This is right skewed or positively skewed. where you have a longer tail to the right. Here you can see the last line on this slide. If the data is skewed, appropriate measure of central tendency is median. I have already discussed this. This is negatively skewed where you have a longer tail to the left. You have a longer left tail. Then lastly, we have kurtosis. Kurtosis also tells you about the shape. This measures the peakness or the flatness of your data. You can see 3 different types of classification of kurtosis on the right. If the curve is flat, it is called platykurtic. If it is normal, it is called mesokurtic. And if it has a longer peak, then it is known as leptokurtic. Okay, now this is just a summary of what we have already discussed. Now, since the lecture is just for an hour, so taking 2-3 minutes extra and telling you all briefly about our software, which we begin tomorrow. Now, R is basically a programming language, and it is an open source and free language. Okay, now just a very quick question to all of you. Do you all know the difference between free and open source? What is the difference between free and open source? Is it the same thing or there is any difference?
Ma'am, I believe free is like anybody can use it. Open is something where like the programmers, they would update the version every time. They can add into it.
Free is something which anyone can use, and open source is like anyone can use that model and edit it.
Very good.
According to their
answers, yeah. So both of you have answered correctly. Open source means that there is a group of people, there are a group of programmers from among the users only who can add to the software, who can modify. Not everybody can do, but yes, anybody from public can enter that domain and can add to that programming language, can enhance that programming language. That is open source, which means you can change the source. Not everybody, but those who qualify from among the users can add. And free means that, yes, it is freely downloadable. Anybody can use it. Now, R was basically developed as an answer or as a replacement to an S language, which was very expensive. Our software is not a very, very old one. It started in the year, it was conceived in the year 1992, but the initial version, as you can see, was released in 1995. Current version of R that you all will be downloading is 4.4.1, which was released on 14 June this year, like couple of days back, 21 days back. Our software has more than 20,000 packages that are available. What packages means? For different operations, for different statistical functions, for different calculations and analysis, there are different packages that are available. In order to do that calculation or do that analysis, you have to download that package first. So when we will work on R, I will tell you all how to download a package and how to install that package also. So there are some functions which are available in the base module also, but for most of the functions, most of the analysis, we have to download a specific package, which we will understand as we will start working on that. This is basically a programming language, okay? You have to write codes, and using those codes, you have to run them, and then you will get your results. This is how we can download R. I think you all can maybe take the screenshot of this slide. Although I will send this link to Dr. Dharmendra and he will be sharing with all of you. Just write download our software on Google or just write CRAN R project. You can see on the screen. And this is the type of, just click on cranrproject.org. This is the official website from which you will be able to download R programming language. And this is the dialog box that would open. Request you to share the PPT. Yes, I'll do that. So this is the dialog box that would open, if you can see on the screen. If you people have Mac or iOS, then you can download R for Mac. If you are using a Linux operating system, you can download it for Linux. And I think most of us use Windows, so we will be downloading R for Windows. Okay. It will be good if you all are able to download R before tomorrow's lecture, so that we can all start working on R software. Although I will be sharing the codes with all of you. So even if you are not able to do it with me, you can do it later on also. But please try to download the software at least. Okay. This is how you can download R. Now we will be working on R Studio. What is the difference between R and R Studio? R is the base console. R Studio is a improved environment. It is, I can say, an extension of R, which has a better interface. Now, why I am saying it has a better interface? As you can see on my screen, in R Studio, we have 4 different sections. We have a code editor where you can write the code. Then you have a section where you will see all the outputs. Then you have section 3 where you can see the history, what all codes, what is the data set, all those things. And then you have a 4th section where we will be able to see the plots, the figures, etc. So R Studio is an improved environment over R. But the problem is R Studio only works when you are able to download R Basic. So for all of you who will be working on R tomorrow, the first thing that you will do is download R. After you have been able to download R, please download R Studio. I will show it to you tomorrow also. I will send both the links to you all. First, download R, latest version of R. And after that, just write on Google R Studio. Okay. And download the latest version of R Studio. Please follow the instructions step by step and you will be able to do it. So I think that's all from my side today. Thank you.